It's time to bust out 3 more quick reviews of derivative rules, and we're going to start with the star of all derivatives, the chain rule. That's what they'd say in a calculus book, but we know it's really called the ninja because it's such a stealthy, sneaky rule. It gets you, and gets you so quickly you don't even know you've been got. So here's my equation, square root of 8 minus 3x. I spot the ninja. By the way, I'm going to do an eyeball adjustment. As I go through this, I'm going to think of it like 8 minus 3x to the 1/2 power. That's my eyeball adjustment. That's an eyeball. So you see my final answer down here, but I'm going to explain a little bit of theory on how I got there. Hopefully you can get there right away. But when I look at this problem or this problem, I realize that there are some layers. It's a square root function, but living inside the square root is this another function. It's a linear function from algebra. So the 8 minus 3x is an inner layer that's living inside the square root function. That's one way I think about it. Another way to think about it is composite functions. In Algebra 2, you learned about composite functions. This is a composite function with the square root function housing the 8 minus 3x function. So it's f of g of x, where g of x, the linear function, is living inside f of x, the square root function. Either way you think about it, doesn't matter. You just have to be able to spot that there's two functions in play here. And now the way I look at it, I take the derivative of the outer layer, which is a 1/2 8 minus 3x to the negative 1/2. And then I tack on the chain rule, or the ninja, which is the derivative of the inner function, which is negative 3. Part of the reason I like these layers is, if you recall, when I take the derivative of that, which is that layer right there, I get a dy dw. When I take the derivative of this, I get a dw dx. And look what happens. Those reduce. And if I multiply across using the symbolism, I get a dy dx. Leibniz, you're so clever. That's your chain rule review. Now let's go to 2 easier rules, the product rule and the quotient rule. My reminder on the product rule is this. When I see two functions multiplied by each other, if I just do that one little thing, put a little jewelry on that function, it reminds me of the product rule. Derivative of the first times the second plus the first times the derivative of the second. And when I did the derivative of the first, here's the first, derivative of the first had a ninja. So I had to spot that ninja. Same two functions, now I'm in the quotient rule. And by the way, when you look at my answer, I ran out of space down here. Bad planning on my part. I have a function that's set up in fractional form. So I'm going to be singing here shortly. This is the high part and this is the low part. And so the song you may remember is this. To do this derivative, low d high minus high d low all over denominator squared. What's happening is low, the low part of the fraction, d high, derivative of the high part of the fraction. Low d high minus high part of the fraction times the derivative of the low part of the fraction. Low d high minus high d low all over denominator squared. So if you sing that song, it's going to help you with the quotient rule one more time. Low d high minus high d low all over denominator squared. Quick review. See ya.